Okay, our last problem here in this section on calculating concentration has to do with interconverting concentration terms. And looking at our handout from class today, we're going to be kind of using this bottom figure, particularly for part C, where we need to interconvert molality and molarity. And what we'll see here is that there's several pieces of information that we need to make sure we utilize. We need to be able to utilize molar masses, and importantly, to go between mass of solution, which is used for molality, and volume of solution, which is used for molarity, we'll need to make sure we have density. And for this problem, it is provided. Okay, so this problem talks about hydrogen peroxide, and you can purchase it as a very concentrated solution as a 30% solution by mass. Now this is different from the solution that you have in your medicine cabinet, which is probably about a 3% solution. So this concentrated solution is used in rocket fuel and in a little bit more dilute solution in hair bleach. So they tell us that we have a 30% by mass solution, and again, we just indicated if we're going to convert into molarity, we need to know the density of the solution, so they give us the density of the solution. But they want us to calculate molality, mole fraction peroxide, and then molarity for this solution. So let's pick apart part A, and let's think about how we'd handle this problem. So what I want you to do when you think about these problems is remember what we need to have for molality. Molality is going to be equal to the moles of your solute, which in this case is hydrogen peroxide, over kilograms of your solvent, which in this case is water. Okay, and just to refresh your memory here with this, right? Molality is the moles of solute, which is hydrogen peroxide, over the mass in kilograms of your solvent, which is water. Okay, so clearly they don't tell us moles of peroxide, and we don't know anything about the mass of water that's there. All they tell us is that the solution is 30% hydrogen peroxide by mass and has a density of 1.1 grams per milliliter. So we need to think about how we can use this information to get moles of peroxide in kilograms of water. Well, as I told you on the last problem, anytime you see a percent, what I want you to think about is in every 100. That's how we can take a percent and convert it to a ratio that we can then use in dimensional analysis. So what we can think about is a 30% solution means that we really have 30 grams of hydrogen peroxide in every 100 grams of solution. Well, since we know the only other thing that's in the solution is the solvent, which is water, hopefully it makes sense to everybody that this really means that there's 70 grams of water and 30 grams of hydrogen peroxide in a 30% by mass hydrogen peroxide solution. Now we're starting to get to pieces of information that we can utilize here. Clearly, it's just a grams to kilograms conversion to get the grams of water that's in the solution into kilograms. And using the molar mass, we can convert 30 grams of hydrogen peroxide to moles of hydrogen peroxide. So this is going to be molar mass. And then this is just a simple unit conversion. Okay, we can probably even do that one in our head and get it that it's 0.07 kilograms. But let's go ahead and do our molar mass conversion. So we've got 30 grams of peroxide, 1 mole of hydrogen peroxide is 34.02 grams, 0.882 moles of hydrogen peroxide. So our molality is going to be equal to 0.882 moles of hydrogen peroxide over 0.07 kilograms, and that equals 12.6 molal hydrogen peroxide. So I know that problem may have seemed a little bit scary at the beginning because we knew what molality was, we knew the pieces that we need, but we certainly weren't given it. But remember, take the pieces of information that you're given and see if you can work that in some way to get the pieces of information you need. That's the difference between one of these basic skill problems where the information is pretty much given to you just as you need it, and one of the more advanced problems where you do need to use some more pieces of information to get you to the information you need. Okay, Let's go on to this next problem, what has to do with mole fraction. Now this problem becomes a little bit more simple since we've done some of this preliminary information and becomes a little bit more like problem 13.4 that we just did previous. So if we want to figure out the mole fraction of hydrogen peroxide, that's just going to be the moles of hydrogen peroxide over the total moles. Well, we just figured out the moles of hydrogen peroxide in this solution in this part. So this is going to be 0.882 moles. So part of this problem is already done. What we just need to figure out is the number of total moles we have, which is the moles of hydrogen peroxide plus the moles of water. Well, again, in part A, we figured out the mass of water that we have. So we knew that we had 70 grams of water. So 70 grams of water, 1 mole of water is 18.02 grams of water, and that's 3.83 moles of water. So now we have the parts that we need for this mole fraction. Mole fraction, hydrogen peroxide equals 0.882 moles plus 0.882 moles plus 3.83 moles. That equals 0.185. Again, remember, there's no units with mole fraction. It's really just representing the ratio between the moles of one part to the whole. Okay, moving on to part C, and I'm going to go on to another piece of paper for this. We need to calculate molarity. And even though molarity is the first calculation you learned how to do and a fairly straightforward one, converting between the two of them can be a little bit challenging. So again, I'm going to flip onto a new piece of paper here to solve part C. So molarity is going to be equal to the moles of our solute, which in this case is hydrogen peroxide, and we've already figured that out, over the liters of solution. And this is where this problem gets challenging because we've never talked about the volume of solution we had. We did talk about the mass of solvent that we had, and we know again the total mass of the solution that we have, right? We can say that we have 100 grams of solution, but we don't know what that volume is. But again, interconverting between mass and volume can be done with density. So always think about walk-betweens that you have. For example, if you want to go between mass and moles, that's molecular weight. If you want to go between mass and volume, that's density. So a lot of the more challenging problems come where you have to use some type of an equation or a relationship to interconvert between terms. Okay, so again, we already know the moles of hydrogen peroxide. We actually already got that from our previous problem, right? That's going to be 0.882. We need to figure out the volume of a solution that we have. I'm going to show you another way that you could set this up without having done some of the previous steps. So say you were just given this problem and all you were going to do was start to figure out the molarity. One of the things that you can do is just start with pieces of information that you know and walk to where you want to go. That's a phrase that I use a lot when I'm talking about dimensional analysis. Start with what you know. For example, we know that there's 30 grams of peroxide in every 100 grams of solution. And think about where you want to go, which is moles of hydrogen peroxide and liters of solution. So we talked about interconverting grams and moles is simple using molecular weight. And to go from grams to liters, that can be done if we know the density of the solution. So let's see if we can walk through this problem from the start just using unit conversions. So again, 30 grams of hydrogen peroxide and 100 grams of solution. And just to remind you where we got this from, this is from using the phrase in every 100. And so we knew we had a 30% by mass solution, which meant that there was 30 grams of our part in every 100 grams of our whole. Okay, so we can walk between the mass of the solution and the volume of the solution given the density, which is 1.1 grams of solution in every 1 milliliter of solution. Now we need to get to liters of solution, so we'll have to put in an extra term here, which converts milliliters to liters. Now let's just take a quick check and see where we are with our units. Now, if we stopped at this point, we'd have grams per liter. That's not exactly where we want. We want moles per liter. But again, the walk between for grams to moles is molar mass. So 34.02 grams of hydrogen peroxide in every 1 mole of hydrogen peroxide. Carry out this math, and again, now we're going to have grams cancel, and the units that we're left with is moles per liter. Gives us 9.79 molar peroxide. One of the things that I just want to take a second and point out here is remember that this same solution had a molality of 12.6 molal. So I'm just going to put that there, 12.6 molal. When solutions are fairly dilute, molarity and molality will be fairly similar because the solute is not taking up that much space. But in this case, our solute was 30% by mass, so it was a fairly significant contribution to the solution. So in this case, there will be quite a difference between molarity and molality.